As we've seen previously, often when we convert a fraction to a decimal, it turns out to be a repeating decimal. For example, we can see working by hand that if we convert 2/3 to a decimal, right, we'll divide 3 into 2. 3 goes into 26 times, with 2 left over. And now we see that this remainder 2 repeats, the digit 6 will repeat, 2/3 is 0.6, with the 6 repeating forever. If we enter that on the calculator, we see the calculator show us a bunch of 6's followed by a 7. Of course, the calculator can't show the digit 6 repeating forever, because the screen only has space for so many digits. Where does that 7 come from? The 7 comes from the fact that the calculator rounds the last digit. And in this case, the calculator rounded up, because of course the next digit is another 6. But we know, because we're smarter than a computer, that fractions converted to decimals always either end or repeat. And we know, looking at this, that it certainly looks like the pattern, just the digit 6 over and over again, is what's repeating in this case. Let's see an example that we don't necessarily want to work out by hand, and see if we can find the repeating decimal pattern. Let's suppose we wanted to write the fraction 53/27 as a decimal. So on our calculator we'll say 53 divided by 27. And we see that this is not just one digit over and over again, right? The calculator says this decimal. But looking at this decimal, I think we can see the pattern 962 repeating. Except that 3 there is weird, isn't it? What's going on? Well, of course, if the pattern 962 is really repeating, oh, this must have rounded up. That last digit we see on the calculator is unreliable. So the pattern is the digits 962. We put a bar over the entire pattern. Let's see one more example. Suppose we want to write the fraction 9/14 as a decimal. This one's a little bit harder to see the pattern in, right? The calculator says 0.6428571429. Let's see if we can pick up a repeating pattern here. The first digit I see is a 6. That never repeats. The next digit I see is a 4. Over here I see another 4. The digit after the 4 is a 2. So far, so good. And then, well, I see an 8 and a 9. If the real next digit was an 8, then after that would be a 5, 7, 1, 4, 2, 8, 5, 7, 1, and so on. Is this what I would see? Oh yeah, because if the real next digit was an 8, we would round it up because the following digit is a 5. We get that the repeating pattern is everything from 1/4 to the next. So 9/14 is 0.6428571, with everything from the 4 to the 1 repeating, but the 6 not. Again, how did we find that? We looked for the first time a digit was repeated, and then we checked the rest of the pattern.